Hi, I'm Lindsay Pease, and I'm the Nutrient and Water Management Specialist up here at the Northwest Research and Outreach Center. Today, we're going to give you a little bit of a quick view into our conservation drainage plots that we have here at the Northwest Research and Outreach Center. So behind me you see two lift stations, and these lift stations, the one on my right is pumping water out of the drainage plots that are right in front of me that you will see later. The one on my left hand side is a surface lift station, and that collects the surface water from ditches that we have that move through the field. It collects in these surface inlets, runs into this separate lift station. The reason why we have two lift stations here on these drainage plots is so that we can keep the surface runoff separate from the subsurface water, and then we can get a really accurate picture of what we're looking at either from the surface or from the tile. And the motivation behind these plots is really to take a look at how just normal agricultural practices are influencing water quality in the field. But we've also stacked on top of that some other really cool experiments. The first one being that we're going to be looking at how long it takes for the soil to recover after our subsurface drainage installation. This 60-acre field that these subsurface lift station and the surface lift station are draining is broken into 4 plots. The first plot has subsurface drainage, then we have another plot that is only surface drained, then we go subsurface drainage and surface drainage only again. And the point of these 4 plots is to look at the difference between the soil when it's been drained and when it's been left undrained. So we've got each of those 4 plots. They're each about 15 acres, and we're starting to look at how each of those plots are going to respond after the disturbance that we see in the compaction from installing subsurface drainage systems. As you can imagine, it took a lot of heavy machinery to get these lift stations put in, and then the drain plows themselves are also big, heavy pieces of equipment, all on top of that very wet fall that we had in 2019. When we were just waiting for a string of a few days when we could get out and get this done. Much like the rest of you, it was a challenge for us to get these drain plots installed as you are all trying to finish up your field work as well. So what we have been seeing, which I think is really interesting right away, is the visual difference in the soybeans between right where we're near the lift stations and where we had the most equipment driving and compaction issues. We had emergence issues, but we also have emergence issues where in the surface ditches where the surface water has been sitting, since we've also, in addition to our wet fall, had a very wet spring and early summer. So I think this is going to be a really neat short-term visual assessment that we can do on these plots is looking at yield challenges with compaction versus yield challenges with surface runoff. The third experiment that we're doing out here is we are looking at how subsurface drainage installation impacts nutrient cycling. This is a funded research project that's funded by AFREC and by the Minnesota Corn Growers. And for that, we are looking at how the addition of subsurface drainage in our drained versus undrained plots are influencing how carbon, nitrogen, and phosphorus cycle in the soil profile. And for that project, I've teamed up with a couple of our other experts, including Dr. Anna Cates, Dr. Fabian Fernandez, and Dr. Jeff Strock, to really dig into some of those nutrient cycling interactions with subsurface drainage. I'm going to give you guys a quick look inside the control panel of our lift station so you can see a little bit more about how these systems work. Inside this control structure, and I will say this is for the surface lift station, but the tile lift station is exactly the same. We've got several controls in here. One of them is to control the pump, and this one has a switch that's either automatic or manual. Automatic means that once the water level rises to a certain level, the pump will kick on by itself, and the manual setting will make sure that you have to tell the pump when to pump. So, you definitely, if you aren't going to come out and manage your outlets actively, you want to make sure that your pump is on automatic. Otherwise, you could end up without any water pumping at all. So if I turn on the system here, it will get electricity to the control panel. The other feature of this is that we have a heater, and the heater will help keep water from freezing inside the tiles even during our cold Northwest Minnesota winter. So we can actually turn off these pumps in the winter when we don't need to be draining and when there won't be any water moving anyway. So that's just an extra feature of these lift stations. Now I'm going to give you a quick look at our automated water samplers. We have one of these at each of our lift stations, and these will take water samples as often as we tell the program to take them. So we actually don't need to be out here to grab samples. We can have these samplers out here all the time to collect water samples for us. And I have one of our new grad students, Aaron. He's here to help me show off our samplers. So I'll have Aaron help me take off the lid. So on top of this sampler, we have a control panel, and this allows us to program the sampler and tell it how often we would like it to sample. Right now, I have each sampler's programmed to take 4 samples every day, and they composite all those samples into one bottle. We have a set of 24 samples in each of these bottles, and again, each bottle takes 200 milliliters of water, and we collect that again once every 6 hours so that we can collect 4 samples a day. And the sampler arm just automatically moves to each bottle, so we know when we come back to collect it which bottles correlate to which samples.